Okay, so coming to stochastic independence, this has been the definition which I have discussed in the previous video. It is that both x and y have joint probability distribution, but they are independent of one another, or the function gy is independent of x. Okay, then you will say they are stochastically independent. Okay, I have a problem here. That is, I mean, an example here. What that is the joint probability distribution function of two-dimensional random variables x and y is given by this. Okay. And then you are asked to find the marginal density functions of x and y. In case I have missed how to find marginal density functions of x and y for continuous random variables, you can just see that in this example. Also, the conditional density function of y given x and conditional density of x given y. Also check for the independence of x and y. Independence here is nothing but the stochastic independence that we'll be checking. Okay, even if I'm asked just to find the independence, I'll be needing the marginal distributions, guys. Marginal density functions. Okay. So anyways, I thought I will take all these questions. Right? Yeah. How do I find a marginal density functions? Density function of x. How do I find? In discrete, anyways, we have seen. In case if I missed out in continuous, then okay. So actually the function is given to me like this. What it is f of x comma y actually is given to me like this. What that is the integrand is 2. Okay, for the limits. Of course, it's greater than or equal to 0 only always. And then double integral x is ranging from 0 to 1. 0 to 1. Y is ranging from 0 to x. Okay, 2 dx dy is being given to me. Of course, guys, you can plot the region of integration and go ahead. Otherwise, normally first you finish off doing integral 0 to 1. Yeah, this should be dy dx actually, because in inner limits are functions of x. So dy should come and then this should be dx. Okay, so 2y from the limits 0 to x and dx. Okay, so it becomes 2x. Integration of 2x will become 2x squared by 2 from the limits 0 to 1. So this value would turn out to be 1. So this is satisfied. F of axioms of the probability f of x comma y is greater than or equal to 0 is satisfied. The total probability is 1. That's also satisfied, right? Now I can go with finding out marginal density functions of x and y. Okay. Now it is nothing but f capital X. This is equal to integral minus infinity to plus infinity f of xy dy of x. I am finding out. Okay. In such a case, x will be fixed, y will be varying. Okay, but anyways, from minus infinity to infinity, the function is not existing. The y limits are only from 0 to x. The remaining values are all zeros. You can just observe. I'll scroll up. Okay, so this comes out to be 2x. I'll just scroll up. You can see the problem. Okay, only for the y limit between 0 to x, the function exists. For any other limits, it is 0. Okay, so this is how I'll find marginal density function for a continuous random variable. Okay. Marginal density function of f of x. F of y, how I'll find out? Just see, guys. Same thing with respect to x, I will be doing. That's it. Okay, minus infinity to plus infinity. F capital X, y, x comma y. I'm calculating also, you'll understand. Okay. This is equal to, yeah, it would be what? Integral x limits. Just see here, x limits are from 0 to 1. Okay. So 0 to 1, 2 dx. Okay. Since, see, when I'm taking y limits, I'm fixing x. When I'm taking x limits, I'll be fixing y. Yeah. Okay. So what I'll be getting is 2 into 1 minus y. Okay. Yeah. Upper limit is 1, lower limit is y. So I'll be getting like this. Now, Conditional probability I will see later. Was coming to the functional, I mean, independence. Okay. Uh, Independence. Actually, it is stochastic independence only. Independence, how will I calculate this? Fx into x, gy into y. There I was checking. Here I'm just using the notation fy into y. Anything is fine. Okay. This is nothing but fx into x, fy into y. This is nothing but I have 2x, fx to be 2x. The other one is 2 into 1 minus y. And what is f of x comma y, guys? What is f of x comma y that's been given to me? F of x comma y that's been given to me is 2. Is it matching anywhere? It's not matching. Or in other words, this product is not equal to this. Hence, they are not functionally independent. Only in the case of, remember, yeah, okay, let me write. They are not independent is what I will write. Only if I'm able to express, then they are independent. Okay, I will tell you one hint, guys, here. One note I will tell you. Independence is possible only when E par things are there. Next video, I'll be doing a problem of this type. Okay, E par x square plus y square or E par x plus y kind, where I can write E par x into E par y. In such a case, only usually functional independence is possible. For polynomials, for other things, it's not possible, guys. This is a hint just for you for examination's sake. It's a shortcut to remember. For any other things, it is not. Only for this polynomial kind, no, only for exponential function it works. Okay. I will just stop this video. They are not functionally independent. I'm sorry, not functional. No, not that word. They're not stochastically independent. Okay, when they'll be independent, I'll just show in the next example in the next video.